Hi everybody, we are up to page 15 in our notes. So 15 in our notes, we are up to trapezoids. So we haven't done one of these videos in a while. Hopefully we all remember what we're doing here, myself included. So a trapezoid is a parallelogram with at least one pair of parallel sides. So that's kind of a key term, at least one pair of parallel sides. So where that puts trapezoids on the family tree we talked about. So there's quadrilaterals. That's just four sides. Below that are trapezoids. So trapezoids are anything with at least one pair of parallel sides. So there's my trapezoid. So below trapezoid, that's where parallelograms come into play. So they have a little more specific about them than the trapezoid. So quadrilaterals have four sides. Trapezoids have four sides with at least one pair of them parallel. And parallelograms have two pairs of parallel sides. So that's where trapezoids are again on that little quadrilateral family tree we talked about. Alright, so there's our first definition of a trapezoid. At least one pair of opposite sides are parallel. And there's the second definition. So at least one pair of opposite sides are parallel. And in this case we can see there are our parallel sides. Alright, if you need another minute to keep writing those down, go ahead and pause, but I'm going to keep going because you guys are able to pause. Now it also says that two pairs of consecutive angles are supplementary. So two pairs of consecutive angles are supplementary. So we go back to our parallel lines cut by a transversal. So there's our parallel lines. There's one option for a transversal. There's another option for a transversal. So what that tells us, remember we think about all our parallel line cut by a transversal rules. That tells us this angle and this angle are same side interior, so they are supplementary. Two pairs of consecutive angles are supplementary. On the other side, it's the same thing. So this angle and that angle are supplementary. Alright, so in a trapezoid, two pairs of consecutive angles are supplementary. Now, a little more common for Regents tests and proofs and stuff, we're going to have isosceles trapezoids. Now, isosceles trapezoids are just like isosceles triangles in that we have two sides that are congruent. Alright, and for a trapezoid, those congruent sides will be the non-parallel sides. So isosceles trapezoid, the non-parallel sides are congruent. Also like an isosceles triangle. Isosceles trapezoids have two pairs of congruent base angles. So those two are congruent, and these two base angles are congruent. Alright, so that's what we also know about an isosceles trapezoid. Third, again, pause if you need to. This is a rule that you have to be careful with. The diagonals. The diagonals are congruent. So diagonal right there and diagonal right there. Let me get a straight line out actually. So the diagonals are congruent. Notice though, do those look equal? Does it look like they bisect each other like we talked about in class? You can use the picture. Use the picture. I know I always say it's not drawn to scale, but you can use it as a guide. These diagonals are congruent, but they do not bisect each other. So what we can actually label in the picture is that these two pieces are congruent. And these two pieces are congruent. So that's a really common question you'll see. It'll say like, in what type of quadrilateral are the diagonals congruent, but they do not bisect each other? And your answer for that is always going to be an isosceles trapezoid. All right, So a couple quick examples. You know what? Why don't you do, this is one of those cases, I want you to try it on your own. So label the, just a matching game. The bases, the legs, the diagonals, base angles, opposite angles. Go ahead and match them. I'll write the answers after you unpaused on the left-hand side here. So go ahead and pause now, and when you come back, I will have the answers there for you so you can see how you did. Pause now. So there's your answers. Hopefully you got those right. Here's the one that I put a star next to, and actually they match up right across from each other. P, Q, and RS, those are the congruent, or actually not even matter if they're congruent, they're the non-parallel sides. So in a trapezoid, the non-parallel sides are called the legs. And actually just like an isosceles triangle, same terminology there. Alright, so check those answers, make sure you got them right. Base angles, the bases are the parallel sides. Really important to have that vocabulary. Alright, so let me grab my pen back. So leg, leg, and these are the bases. The parallel sides are the bases. Okay, next. Just another example of using it algebraically. So an isosceles triangle, MATH, MT, which is right there, equals 6x minus 2. AH, which is the other diagonal, is 4x plus 8. So they give you the lengths of the two diagonals, and in an isosceles trapezoid, the diagonals are congruent. So we set them equal, and we're left with 2x equals 10, x equals 5, and we're done. Alright, isosceles trapezoid, the legs are congruent. So the legs are here and here, and the diagonals are congruent. So a few more rules, things that will be helpful in some of these algebraic questions. All right, last thing for this whole unit. Next page. The mid-segment theorem for trapezoids. So I'm going to pause, and you guys can write this on your own. But the mid-segment of a trapezoid is the segment connecting the midpoints of the legs of each side. So it's connecting the midpoints of the legs. So midpoint, midpoint. So this here is the mid segment. Alright, so I'll pause while you finish writing down. Pause now. Okay, so that mid segment is parallel to the two bases. So we still have alternate interior, corresponding angles, all that good stuff still applies. Those parallel lines. And the mid-segment is half the sum of the bases. So an easier way to say that is it's the average of the bases. So add them up, divide them by 2. So here's what you will see. Alright, so A, the mid-segment, is the average of the bases. So 14 plus 7 divided by 2. 21 divided by 2, x equals 10.5, and you're done. All right, the mid-segment is the average of the bases. So let me show you two ways to do letter B. We can see in this case we have the answer basically. We know the answer to this question. We have to work backwards and find out what this other base is. So what you can do is say, the average of the bases is 24 plus x divided by 2. The answer to this question is 13. So we know that 24 plus x divided by 2 equals 13. So now we can do that. We cross multiply. We're left with 26 equals 24 plus x. Right? Multiply this way, multiply that way. And we have x equals 2. Let me show you a little easier way to do this. So if it's the case where we have to work backwards, actually it's a lot like the midpoint formula we did earlier in the year. So for letter A, it was easy just to do the average. Letter B, we can see there's a little more math to do. It's not that hard, but it's something you can do. Watch another way to do it. We just want to find that pattern. So to go from 8 to 11, to go from basically the base to our midpoint, we're going plus 3. So, it makes sense, since it's the midpoint, to go from 11 to our other base, we're just going to go plus 3 again. So that's a little easier way to do it. If you know the answer you can work backwards and use that same kind of pattern we did for our midpoint formula. All right, so mid-segment theorem, that mid-segment is the average of the length of the bases. All right, last one. EF, we know that is 10. We know AB is x plus 5, and we know DC is 2x minus 3. So in this case, we have to do a little bit of math. We have to do a little bit of algebra. We know the answer is 10. We know the average of these two bases is 10, but we don't know what those bases are. So in this case, we just have to set up the algebra. So we know the average of the two bases. So you add them up and divide by 2. So the average of the base is x plus 5 plus 2x minus 3 divided by 2 equals the mid-segment. So the average of the bases, x plus 5 plus 2x minus 3 divided by 2 equals the mid-segment. So here, same thing, we can just put that over a 1, cross multiply, and this becomes a pretty quick question to solve for x. So we have 20 equals combine like terms, subtract 2, 3x equals 18, x equals 6. And we make sure we answer the question, which we did, and we're done. All right, check your work if you want. 6 plus 5 is 11. 2 times 6 is 12, minus 3 is 9, and that actually follows our pattern. So 11, there's my values, 11, 10, 9, there's the average. That looks like it worked out. All right, 4 questions on your online homework check. Guys, don't forget your Regents Review number 9. Please turn those in on time, and we'll do some test review when I see you next time. Goodbye.